In this video, we're going to talk about linear speed and angular speed. Linear speed is the measure of how fast the position of a point is changing. So for instance, if you were driving down the road in your car, it would be measuring how fast your car the distance that you're traveling in your car is changing over a certain amount of time. But in this chapter, we've been talking about circular functions, so we're going to talk about circular distance. So in this chapter, when we talk about linear speed, we're going to be talking about how fast a point on a circle, let's just call this point B, how fast that point is moving around the circle. And in order to do that, we need to calculate its arc length and then measure the time that it takes to go from point B to point P. So that arc length and the time. So we call it linear speed. Another word for linear speed is velocity, V, and we're going to use the same letter that they use in physics to represent linear speed. So our velocity or linear speed is going to be the distance our point traveled along the arc of a circle, that's our arc length, over the time it took for that point to travel that distance. Another formula we could write for velocity, since we do know the formula for our arc length, is theta r divided by t. So those are the two formulas at this point that we have for linear speed. Now, linear speed is a ratio of distance to time. So we call a ratio of distance to time a rate. And our distance can be measured in numerous different measurements. We have miles and kilometers and centimeters and inches and feet and yards. So there's many different ways that we can measure distance, and we've done that already in grade school. There's also many different ways that we can measure time. Time can be measured in hours, days, weeks, years, months, so on and so forth, seconds and minutes. So our rate for linear speed or velocity can be measured in miles per hour. It can be measured in kilometers per second. But again, it is the distance traveled along the circumference of a circle. So now let's go ahead and move on to angular speed. What is the definition of angular speed? Angular speed, as the word suggests, an angle, also has to do with circular motion. If we take a point B on a circle and that point starts moving, it ends up at position P. Here's a nice angle that movement created along our circle. Angular speed is how fast the angle POB is changing over time. How fast does that angle change over time? So as opposed to linear speed, which deals with arc length, right, the distance something travels, this is the angle it travels through given a certain amount of time. The variable that we use for angular speed is called omega. It's a little fancy small w, and omega equals the angle that the object moved through over the time that takes the object to move through that angle. So angles are measured in degrees, radians, revolutions. We've seen degrees for forever. Radians is something that we just learned, and then revolutions we've seen in some of our word problems. Time, again, can be measured in days, hours, weeks, years, months, seconds, minutes. So again, angular speed is a rate because it's a ratio of an angle measure over the time it takes to travel through that angle. So our angular speed could be measured in degrees per week, radians per day, revolutions per year. So it is definitely a rate, but its default value, unless otherwise told to do so, you should be measuring your angular speed in radians. This should be a radian measure. So make sure that you, unless told otherwise, make sure that your angle is measured in radians. So let's go back to the definition of our linear speed, because I want to point something out here. Theta over t. We just define angular speed as theta over t. So we can add another formula for finding linear speed. So we can replace theta over t with omega. And so another way of calculating linear speed would be our angular speed times our radius, omega r. So those are 3 ways that we can calculate linear speed. We have one way to calculate angular speed. So let's move on to a couple of quick examples here. So I've got my little formulas on top, and we'll use those formulas as we solve this problem. So given a circle with radius 30 centimeters, an object traveling around the circle that travels through pi over 10 radians every second, and that this object travels for 4 seconds. If we call this object P and it's traveling on this circle, find the angle made by P in time t. Well, we have been given R, we've been given omega, and we've been given t, and we need to find theta. So if we take a look at our formulas up here, I think that our angular velocity or our angular speed formula works really good because we have omega and t and we're looking for theta. So let's go ahead and use our omega equals theta over t and plug in the information that we have. We know that our angular speed is pi over 10 radians per second. And we're going to set that equal to theta, which we're looking for, over 4 seconds. So when we multiply both sides by 4, we get 4 pi over 10 equals theta, or when we simplify, theta equals 2 pi over 5 radians. So the next question is to find the distance traveled by P in time t. So distance is definitely arc length. So our distance that we travel around the circle is the arc length over which we traveled. So our formula for arc length is S equals theta r. We know that the angle that we traveled through in 4 seconds is what we calculated in part A. So we're going to use 2 pi over 5, and then we're going to go ahead and multiply that by our radius, which is 30 centimeters. So when we simplify that, we get 12 pi centimeters. So it traveled over an arc of 12 pi centimeters. Lastly, it does say find our linear speed. And since we have our arc length and we have our time in which we traveled, we're just going to use the very first definition we learned, that our linear speed is equal to our arc length over time. We just calculated our arc length, 12 pi, and we're told our time is 4 seconds. So our linear speed is 3 pi centimeters per second. All right, so now let's move on to another problem. I'm going to leave my formulas down here at the bottom of the page. It says, find the time it took P to move through an arc length of 6 pi centimeters on a circle with a radius of 2 centimeters, traveling at an angular velocity of pi radians per second. So let's take a look at what we are given. We are given that the arc length, which is S, equals 6 pi centimeters. We're also given that the radius of the circle that the object is moving around is 2 centimeters, and that it's traveling at an angular speed or velocity of pi over 4 radians per second. And they're asking us to find the time. So by glancing down at the formula, I have SR and omega, and I need to calculate T. So I see two formulas for velocity that have only those four variables in it: my arc length, my time, my angular speed, and my radius. So let's go ahead and set it up to solve. So we're going to use these two formulas, we're going to set them equal, and we're going to plug in the information that they gave us. We have 6 pi centimeters over T, which we're solving for, equals omega is pi over 4, and we're going to multiply that by our radius, which is 2. When we multiply both sides by T and simplify, we get 6 pi equals pi over 2 times T. When we solve for T, we get T equals 12, and because our angular speed was measured in seconds, our time will be measured in seconds. 12 seconds. Thank you for watching, and if you need more examples on linear speed and angular speed, there's another video on my YouTube channel that you can watch.